So now we have the another problem called climbing stairs. This is another problem where we actually first talk about the recursive way, then I will just tell you what is the problem in the recursive way, and then we'll just go to the dynamic programming approach. The problem statement is if you are climbing an stairs and it takes n steps to reach at the top. So suppose there are stairs, right? It takes n steps to reach at the top. So the constant is each time you can either climb 1 or 2 steps. So each time you can either climb 1 step or 2 steps at a time. Means from here, right? If you are at the base position, you can climb to this, either this, or you can climb to second directly, right? So there are two ways. From this position, either you can climb to this, or you can climb to this directly. So there are two ways to climb this, right? Either you can take 1 step at a time, you can take 2 steps at a time. You actually need to tell how many distinct ways you can reach at the climb. How many distinct ways you can reach at the climb. So the constant is basically simple. Like if you are n equals to 0, right? If there are 0 steps, so you have a 0 as a result, right? You have 0 ways to reach at the top. If you have 1 step, right? If you're just one step, so you just have one way of reaching it. You just take like from 0 to 1, this is one way. If you have 2, 0, 1, 2, then you have two ways actually. You can either go from 0 to 1, right? Or either you can go from 0 to 2. So you have two ways. So you can see the pattern, right? So this actually for 0, it's 0 ways. For 1, it's 1 ways. For 2, it's 2 ways. Similarly, let's say it has 3, or I will take here 0, 1, 2, 3. So what you can do, like firstly you can go from, like what are the combinations? So you can go to like 0 to either 1 or 0 to either 2, right? Now you can go from like 1 to directly 3, or 1 to directly 2 and 1 to directly 3 and 2 to 3, or you go to 0 to 1 then 1 to directly 3. These two ways. Now you can go to 0 to directly 2. Now you can go to only 3, right? 0 to only 3. Because 1 we have covered. Like if you go from 1, now you have 2 choices. Now if you go to 2, you only this many choices, right? So if you take example of this one, right? You have actually 3 steps, 3 ways. For 3. So if you see, like whenever you standing at any step, right? So at any step, actually it's the number of ways to reach this step is the sum of the previous two. If you see the relation here, right? So we made a relation here. So if we are here, so to reach here, it is actually the sum of last 2 steps. To reach here, actually the sum of last 2 steps, because this to reach here, you can be either here or you can be here. So number of ways to reach here plus number of ways to reach here. This will give the answer for this, right? What will give you the answer for this? The number of ways to reach here plus the number of ways to reach here. The sum of last 2. That's a Fibonacci series. Again, like a Fibonacci series. So that's how we generated a relation between this race step. So this particular result is actually the sum of last 2. This particular result is actually the sum of last 2. So this way we actually generated the relation, and these are our base condition. So we can see that like this is an example of a proper recursive program. So what will be the solution of this? So the solution of this is suppose there is a function climb something like that, and here you have given the top position, right, where you want to. What will be your base condition? What will be your base condition? So if n is less than equals to 2, right, because we have seen here for 0 it's 0, for 1 it's 1, for 2 it's 2. So if n is less than or equals to 2, we need to return n, right? Otherwise what you need to do, this is actually the if, otherwise what you need to do, you actually need to return the sum of last two. So you need to return, you will call climb, that is n minus 1 plus climb of n minus 2. So this will be your recursive program. So if you wanted to work for, like, let's suppose n equals to 6, right? So you will call like function of 6 here. Function of 6 will call n minus 1 and n minus 2. So it will call f of 5, f of 4, right? And you need to return the sum here. F of 5 to calculate, you need to do f of 4 and f of 3. It's the sum here. To calculate f of 4, you need to do f of 3, f of 2, right? It's the sum here. To calculate f of 4, you need to do f of 3, f of 2. To calculate f of 2, you need to do f of 2 plus f of 1. To calculate f of 3, you need to do f of 2 plus f of 1, right? So if you see, like, these are the leaf nodes. Now we reached our base condition. So like I explained you in the introduction of the dynamic programming, these are the leaf nodes. These all are the leaf nodes, right? So it will return 2 here, because like as per our base condition, like whatever is the value of n, it will return. If it is 2, this will return 1. So f of 3, we have 2 plus 1, that is 3. F of 2 will return, actually this function will return 3. This function will return 2, because f of 2 is 2. So f of 4, we have 3 plus 2, that is 5. So this function will return 5. This function will again x1 f of 2 plus f of 1. This will return 2, this will return 1. So this is 3. So f of 5 is 5 plus 3, that is 8. This will return 8. This will return 2. This copy will return 1. F of 3 will be 2 plus 1, that is this will return 3. F of 2 will return 2. This will return f of 4 will be 5. So f of 6 will be eventually 8 plus 5, that is 13. So 13 is your answer. So this is a very recursive approach of this way, and this is the program. So we'll do it on the Leet code. Thanks.